So let's look at question 1. The t-test is used to test the statistical significance of a difference. What is that difference? So when we're talking about the t-test, what we're talking about is we're comparing two groups of data. So to draw it just down here, perhaps we'll have a group of data. Let's draw our x and y axes here. So x-axis and also y-axis here. So our first group of data might be spread in a normal distribution along like this towards the start. And then our second set of data, which we'll mark in red, is going to be spread out like this. So it's higher than the first set of data. And both of these have a mean, which is sitting approximately there for the second set or higher data. And the first bit's mean is here. So let's call that mu1, and the second set's called mu2. Now, when we're talking about the t-test, we're actually comparing these two, and we're comparing mu1 and mu2, or we're comparing the mean. So this makes it really easy to answer this question. So in this case, we're comparing the means of two samples. Or answer B. And now let's look at why some of the other answers are wrong. A, between observed and expected results. Now this is one of those answers that just tends to confuse you. It seems like it's relevant, but it's actually not relevant. So just ignore that one. Between the standard deviation of two samples. Now if we're comparing the standard deviation of two samples, we'd be comparing the spread of these two. So say from this point over here to this point, or comparing from the red point all the way over here. And in fact, with a t-test, you're not comparing the spread of the data. The standard deviation itself is what is used to compare the spread. So it's not C. And finally, let's consider D, between the size of the two samples. I mean, this is fairly obvious that it's the wrong answer, because the size of two samples, the size of one sample would be a number. So it might be, if you had 57 points in the first set of data, it'd be 57, and you can compare that with the second set of data that might have 59 points of data. So you don't use the t-test to compare these two samples. So it's not D, therefore it's B. Okay, so that's the first point. And now let's move on to the second question. Second question, what does a small standard deviation signify? Really easy question, but to go through some of the basic theory, again, we're just going to draw our data which follows a normal distribution. A normal distribution has a mean at the center at approximately, let's call it mu again, and it also has a symmetrical kind of shape like this. So one standard deviation for a set of data which is normally distributed, it can tell you about the spread. So if it has a small standard deviation, as in this question, what that means is that the data is spread very closely around the mean. Whereas if we were to draw another one, let's draw another one in red, which has a large standard deviation. In this case, we've got another mean. Let's call it mu2. And in this case, remember that with the standard deviation, that around the mean, plus or minus one standard deviations, 68% of the data is going to be there. So let's say from here to here. So this is minus one standard deviation for the red one, and this is plus one standard deviation for the red set of data. So as you can see now, the spread of data is much greater than the black set of data. Now let's relate it back to the question. What does a small standard deviation signify? The data is not correlated. No, once again, one of those answers which tends to confuse you, but is not really relevant. The data is widely spread around the mean. No, because that's what a large standard deviation would suggest. as we talked about in the red example. So not this one. C, the data shows a close relationship between two variables. Very similar to A, we're not really talking about the relationship between two variables with standard deviation. With standard deviation, you have to remember that standard deviation is associated with spread. Okay? And so a high standard deviation means a high spread. Just keep it simple. A low standard deviation means low spread. Once again, irrelevant. So therefore the answer is D. Let's move on to the next question. Once again, we're talking more about standard deviations. The lengths of a sample of tiger canines were measured. 68% of these lengths fell within a range between 15 millimeters and 45 millimeters, with a mean of 30. What is the standard deviation of this sample? So you have to recognize this number. 68%, big number. The second number that you need to remember is 95%. So 68% of a normally distributed, that's what ND stands for, of a normally distributed variable will be within plus or minus 1 standard deviation from the mean. Whereas for the 95% of the normally distributed variable will be plus or minus 2 standard deviations from the mean. So let's draw our graph here. So we need to know the mean as well as the standard deviation. So the mean we've already got here is 30 millimeters. So let's draw that over here. We're arbitrarily, so arbitrarily means randomly going to draw that down here. And this is the mean. And that's where the peak of the curve is. And now we can draw a rough standard deviation curve or normal distribution curve like so. It's a bit wonky, but don't worry about that. This goes down like that. So we know that 68% of these lengths fell within a range between 15 and 45. Let's draw the 15 and 45. You know, it's roughly probably about here. It's 45. 15 is here. And we know that this portion here represents what percentage of the entire population? 68%. And finally, if we go back to our definition, 68% of the normal distribution variable comes within plus or minus 1 standard deviation from the mean. We know that this is the plus 1 standard deviation. This is the minus 1 standard deviation from here to here. So therefore, how many standard deviations do we have between 15 and 45? We have 2 standard deviations. And that 2 standard deviations is 45 millimeters minus this value, or the lower value, minus 15, equals 30. So what is 1 standard deviation? Easy, just divide that 15 millimeters. Therefore, our answer is B, and all the other ones are wrong. Okay? Let's have a look at question 4. The graph below shows the correlation between the biomass of a marine worm and the percentage of organic nitrogen in the sand where it lives. So as you can see, as the nitrogen tends to go up, you tend to get a heavier worm. I'm not sure why that is. What statement can be made from the data? Now this is one of those questions which can trick a lot of people, but in fact it's best to kind of sit on the fence. So A, the increase in the biomass of the worm is due to an increase in the percentage of organic nitrogen. We don't really know that the increasing nitrogen causes the increase in biomass. It's a correlation, not a causation. And that's the same for the point number C as well. The increase in the percentage of organic nitrogen is due to an increase in the biomass of the worm. The bigger worms, they could be excreting more nitrogen. That's a total possibility, but we don't know for sure. So therefore, A and C are removed. How about B? There's no relationship between the biomass of the worm and the percentage of organic nitrogen. Moving back, that's completely false. We can see that there's a massive increase in biomass as the nitrogen increases. So therefore, B is also wrong. How about D? As the biomass of the worm increases, so does the percentage of organic nitrogen. Yep, this sounds very good. It's one of those answers that sits on the fence. There's no suggestion that one causes the other, and this is the correct answer. Good. So the final question, what do the graphs below show? So we've got a graph of what seems to be like the percentage of the population at the different age ranges that are available. And we're comparing both Mexico as well as the United States of America. Or maybe just United States, not too sure. Our questions are down here below. What can we gather from the graph? A, the population in the United States is increasing at a higher rate. Well, we don't even have any data on the rate of population increase right now. So it's another one of those red herring answers, just be careful. So I'm going to ignore that one for now. How about B? Infant death rate is high in both countries. Well, we're talking about percentage of population here. So we don't really know anything about the death rate. So once again, we can ignore B. How about C? Males live longer than females in both countries. So if we compare males versus females, males being the white color versus female, which are in the grey color, you can see that, say in the United States, there are more females alive at 80 plus compared to males. So this doesn't seem to make sense either. So just by ruling out the first three answers, we can see that D is most likely to be the right answer, but let's double check. The birth rate is higher in Mexico than in the United States. Well, this would be true, because if we have a look at the age range of 0 to 4, you can see that there's a greater percentage of population compared to the United States. And some people would say, oh, okay, but you don't know what actual number of births are occurring. We know that the percentage is higher, so the proportion, but we don't know the actual number of births themselves. And you're absolutely right. But this question is, in my opinion, is a bit of a dodgy question, but it's the most correct answer out of all the other ones, because the other ones are blatantly wrong.
So it really helps us out a lot. Visit our main website by clicking on the IB Blueprint logo at the bottom right-hand corner, or check us out on Facebook. Once again, thanks for listening.